So hello guys, in this video we are talking about memory management and Spark bucketing. So let's start. So let's explain in details. Spark uses unified memory model where execution memory is divided into two parts: execution memory and storage memory. So execution memory used for shuffle, join, aggregation, sorting, and temporary computation. Storage memory used for catching and broadcast variable, catching and persist. Key behavior is if execution memory is full, it can evict means remove storage memory and or means split to disk. If storage memory is full, it borrow free execution memory. Note that storage cannot evade means remove execution memory because execution has priority. Execution is a priority. Why this matters? Why this matters? Because avoid job failure due to memory pressure and help. And second point is help optimize catching and performance tuning. So let's discuss about interview questions. First question: what is Spark Unified Memory Management? It is a memory model where execution and storage share common region dynamically, improve memory utilization and reduce out of memory error. Next question: what happens when execution memory is full? Spark evacuates means remove cache, storage block and may split data to disk to free up memory for execution task. Next question: can storage memory evict execution memory? No. Execution memory always has priority over storage memory. Next question: what is spilling in Spark? Spilling occurs when data is moved from memory to disk due to inefficient memory during execution. Next question: difference between cache and persist. Cache is stored in memory only, it is default, and persist it allows storage levels, means memory, disk and serializer, etc. Real world scenario, scenario 1: slow Spark job due to memory issues. Problem is a job performing join and aggregation is running very slow and sometimes fail due to out of memory error. So root cause is expensive data in memory, poor partitioning and unoptimized join. First solution is increase the partition using df.repartition in bracket 200. Next, use broadcast join for small tables like slash from spark.sql.functions import broadcast first, then df.join in bracket broadcast in bracket dimension underscore data frame in bracket comma id in the result. Third point is persist only required dataset using df.persist in bracket. Fourth, tune memory configuration means spark.executor.memory and spark.memory.function. So next scenario is expensive disk split. A problem is heavy disk split during shuffle partition. Solution: we have to increase the executive memory, optimize joins, use proper partitioning, avoid wide transformation when possible. Interview tips are when answering questions. Spark question always concept, problem and solution. Mention performance tuning whenever possible. Next topic is bucketing. This is advanced Spark optimization topic. Bucketing is a technique used to avoid large dataset into fixed number of buckets based on the hash function applied to the column. Formula used internally like hash of column % number of buckets. Unlike partitioning, buckets are fixed in number. Each bucket contains multiple values and avoid full small file problem. Where bucketing helps? For filtering, joining and aggregation in group by. Bucketing versus partitioning. Bucketing based on column value, partitioning based on column value, bucketing based on fixed hash of columns. Partitioning number of split dynamically, and in bucketing number of split fixed. Partition based for low cardinality and bucketing fixed for high cardinality. Partition small file issue we can face, but in bucketing we don't face any small file issue. Next, bucketing for filter. Problem: filtering on high cardinality column without bucketing full scan. With bucketing, with partition, too many small file partition means performance issue. With bucketing, Spark calculate bucket using hash read only relevant bucket. Next is bucketing for join. Without bucketing, shuffle it will first do shuffle, then sort, then merge. It is expensive. With bucketing, small bucket IDs co-located, then avoid shuffle. It is the ideal case. Condition for best performance, like we have to use same column and same number of buckets for each two tables. Means suppose we have df1, df2 and joining, we are joining this table, so we have to do bucketing with same column and same number of columns we have to do for two data points. Bucketing for aggregation. Without bucketing, shuffle required, and with bucketing in aggregation, data already grouped by hash, and hash shuffle reduced and or avoid. Joint performance scenario. Dataset 1, dataset 2. Dataset 1 having bucketed same column, same bucket. Dataset 2 bucketed, then result is no shuffle. Dataset 1 bucketed, dataset 2 not bucketed, then partial shuffle will happen. If dataset 1 bucketed but different join condition, dataset 2 also bucketed but there is no, it will occur full shuffle. How to decide number of buckets? Thumb rule is ideal bucket size is 128 MB to 200 MB. Formula is number of buckets is equal to total size of data divided by ideal bucket size. Means if we have 1000 MB data and bucket size is 200, then number of bucket is 5, because 100 MB divided by 200 MB is equal to 5. So number of bucket size is 5. What is now let's talk about introductions. So what is bucketing in Spark? Bucketing avoid data into fixed number of bucketing divides data into fixed number of buckets using hash function on column to optimize join, filtering and aggregation. Difference between partition and bucketing. Partition is based on column value and create dynamic partition, while bucketing use hash function and create fixed number of buckets. Means partition. Buckets. When should you use bucketing? You can use for high quality columns, frequent join on same column, and large data set. Can bucket avoid full shuffle completely? Yes. If both data set mean data frame are bucketed on same column with same number of buckets, then we can avoid shuffle fully. What is bucket pruning? Spark read only relevant buckets during filtering instead of scanning entire dataset. Again, Spark read only relevant buckets during filtering instead of scanning full dataset. Does bucketing work in Iceberg or data? Modern table format like Iceberg prefer partitioning and sorting. Traditional Spark bucketing is limited or not recommended. Real world scenario 1, repeated join optimization. Problem is joining orders and products daily causes heavy shuffle. Solution is bucket both table on product ID, use same number of buckets, resulting shuffle eliminate and fast join. Second scenario, high cardinality filter. Problem is filtering on product ID take too long. Solution, apply bucket on product ID, result is only relevant bucket scan. Aggregation optimization. Scenario 3. Problem is group by causing heavy shuffle. Solution is bucket data on aggregation key, result reduce shuffle. Tactical code snippet, create bucket table. How we can create? df.write.bucket by in bracket 4 product ID dot mode override and save as table in table name. So it will create 4 bucket based on product ID, and we have to use hash function. Join using bucket tables. df1.join in bracket df2 product ID. Then aggregation using bucketed data. df.group by in bracket product ID dot sum of total count. Common mistake using bucketing with different bucket count. Using different column for bucketing and join. Accepting benefits for small tables. This is about bucketing. let's device